Welcome to our second installment of Geometry at Home. Today's topic is section 1.2, measurement of segments and angles. And today we're talking about how we measure segments, how we measure angles, and the relationship between them. First, we'll talk about the different types of angles that we have. We have four main types of angles that we're going to deal with in this class. The first type is called an acute angle. And an acute angle is an angle that measures greater than 0 degrees and less than 90 degrees. So 0 degree angle does not exist, so we're not going to include that in our acute angles. And it also has to be less than 90 degrees. It could be 89.99 degrees. It's still considered an acute angle. If it's 90 degrees, then it's a different type. An obtuse angle is an angle that measures greater than 90 degrees, but less than 180 degrees. Again, if it's 180 degrees, it's a special type of angle, and if it's 90 degrees, it's a special type of angle. Speaking of those special types of angles, we have a right angle. A right angle is an angle that measures exactly 90 degrees. Not rounded, not pretty close. It's got to be exactly 90 degrees. And you'll have enough information to figure that out. And a straight angle is an angle that measures exactly 180 degrees. And for our purposes in first semester, that's going to be the largest angle measurement that we talk about, something that's 180. Nothing bigger than that. Straight angles are also sometimes called straight lines. They're very similar. So what do they look like? Well, here are the four different types of angles. The first one in the upper right corner here, we have a right angle. Now a right angle, grab my highlighter here, will have a distinctive shape. It will definitely look like an L or some kind of variation of that. It is very important though for right angle that you see that symbol. If you don't see that symbol and it looks like a right angle, that doesn't necessarily mean that it is. And that's going to be one of the main focuses of the next lesson, is not to assume something from a diagram unless you're given that information. Speaking of assumptions, there is an assumption we can make about a straight angle. If something appears to be a straight line, it is. It's very unlikely that if I were making a worksheet or something like that and it appeared to be a straight line, that it wouldn't be. It will be. And that's an assumption that you're going to be able to make, but not until tomorrow. We also have two different types of angles, acute angles and obtuse angles. And again, going along the lines of the assumption, that does look like an angle less than 90 degrees for the acute, and it does look like an angle bigger than 90 degrees for the obtuse. But we don't know that for sure. We'll have information in the problems to tell us it's acute or obtuse or whatever. So here's our first example. Again, notice that we are told that angle D is an acute angle. Well, by definition, an acute angle is between 0 degrees and 90 degrees. So it's greater than 0, but also less than 90. Now, Part A and Part B have a very important word, restrictions. And what that means is to find the values that it's between. So for Part A, we're trying to find the restrictions on angle D. We want to know, what is angle D going to be between? Well, we just said it. It's an acute angle, so that means it's going to be between 0 and 90 degrees. But notice how I wrote that. I wrote that as what's called a compound inequality, where the value you're looking for is in the middle, and then what it's greater than is on one side, and what it's less than is on the other side. So the way we read that is the measure of angle D is greater than 0, but less than 90 degrees. So it's somewhere in between. Again, can't be 90, can't be 0, but anything in between it could be. For Part B, it says find the restrictions on X. A little different problem, but well, we know what angle D is. Angle D is 10x plus 30. So I'm going to take that 10x plus 30, and I'm going to plug it right in there for angle D. And then I'm going to solve my compound inequality. So you'll notice the way I solve this is, here's my setup, 0 less than 10x plus 30 less than 90. Then I took away 30 from both sides of the inequality, so from the middle and from the right and left. So when I take 30 away from 0, it's negative 30. When I take 30 away from 90, I get 60. And then to get x by itself, I divide by 10. So negative 30 divided by 10 is negative 3. 60 divided by 10 is 6. And there's my solution. Negative 3 less than x less than 6. In other words, if x is between -3 or +6, then angle D will be an acute angle. And then our second topic is congruence. Now, two angles or segments are said to be congruent if they have the same measure. Now, we're not really going to measure things. We're not going to pull out a ruler and a protractor and see that, oh, an angle is 27 degrees or anything like that. We're going to have more algebraic statements. It says, angle A is 2x plus 7 and angle B is 17x minus 4, something like that. And then we'll have information related to those. You'll notice that the symbol we use for congruence looks kind of like an equal sign, but it's got that little tilde above it. You're in Spanish class, you should be familiar with that tilde symbol. So here's an example. We are given that segment AB is congruent to segment BC. We are given that AB measures 3x plus 4 and BC measures 5x minus 2. Notice that I'm using different symbols. When I'm talking about the segments but not about their measurements, I use the symbol congruence. When I'm given a statement about how I can find the measurement of the segment, we use the equal sign. It's not related to the two segments. It's one segment is given this measurement. They're not congruent to 3x plus 4. BC is not congruent to 5x minus 2. It equals that. Now, congruence means that the segments are at the same measurement. So I can take the measurement for 3x plus 4 and set it equal to 5x minus 2, and then just solve for x. Well, the way to solve that is I'm going to bring 3x over to both sides. I'm going to subtract it. When I take 3x away from 5x, I get 2x. When I bring -2 over to the other side, I add 2, which gives me 6. And then to get x by itself, I divide by 2. X is 3. Now, if I wanted to go further and actually check to see that that's the right value, I could take that value of x and I could plug it into to segment AB and find out that it's 13. I could do the same for segment BC and find out that it's 13. If those are two segments that are congruent, then they should be equal. And they are. So we probably got the value of x correct. Now our last example, it's the same basic idea, except now we're dealing with angles. So we're given that the measurement of angle CET is 13x minus 14. We're given that the measure of angle NET is 10x minus 2. And we're also told that angle CET is congruent to angle NET, which means they have the same measurement. So just like we did in the last problem, we're going to take these two angles and we're going to set them equal. And we're going to solve for x. So take 10x away from both sides and add 14 to both sides. And you're left with 3x equals 12. Divide by 3 and you have x is equal to 4. Now what's different about this problem from the other one is that we actually have to take that value of x and plug it in, because our final solution is to find the measure of angle CEN. So I have to take that angle 4, or that value of x, which is 4, and plug it into one of my angles. Now I have a choice because those angles are supposed to be the same. So I have to pick one. Well, I think that angle NET would be the easier one to plug in. The reason is I know what 4 times 10 is. It's really simple, and I can easily take away 2. A little more complicated to do angle CET, although not impossible. So when I find the measurement of angle NET, I get 38. Now, according to my problem, CET is going to be the same exact thing. So what I can do next is I can say, well, I know that this one is 38, and I know that this one's 38. Well, I want CEN, which is everything together, so I'm going to take my 38 plus 38, or you can multiply it by 2, and you get CEN is 76. So again, congruence, set them equal, solve for the value of x, and go further if you need to. And that's it for the notes.